All right, folks, let's get back at it with section 1.2, displaying quantitative data with graphs. And right now we're moving to page 2. We're going to start page 2 with a couple definitions. Stemplot. Well, what the heck is a stemplot? Stemplot is a simple graphical display that shows all observations in the distribution. You may have used stem plots before, but called them stem and leaf plots. But now we're big boys and girls, so we don't use the term stem and leaf anymore. We call it what it is. It's a stem plot. Instead of going through the long definition of stem plot, I just give you this general description, and then I thought maybe I would give you a quick example to illustrate the different parts of the stem plot. So I'm going to just list out, let's just go with 7 different numbers here. Let's go 62, 51, 50, let's go 48, 49, how about a 55 and a 58? Okay, whoa, that's not 55 and 58. 55 and 58. Okay, and let's just say that this is, well, I've got to assign some kind of a meaning to these numbers. They're just numbers, but data is numbers with context, so I have to give some context to this. Let's say that is manatee deaths over the past 7 days. Not a good week for manatees. Anyway, okay, so manatee deaths over the past 7 days. All right, so now what does a stem plot look like? Well, the first thing is the stem. And I've got 60s and 50s and 40s. So I'm going to put the tens digit out there, and that is my stem. Preceding digits. All the leaves, which are the final digit of the observation, those are all going to go here. So let's see, we've got a 48 and a 49. I got to include that, so 48 and 49. And then we'll go to the 50s. I got 50, 51, 50, 51, 55, 58. So I got a 0 and a 1 and a 5 and an 8. And then last but not least, I got this last one here at 62. And that's the final final observation for our stem plot. Tough thing about stem plots is that, especially when doing them by hand, you've got to make sure that all of these numbers from one stem to the next are lined up properly. If your writing is, smaller in one stem, you might not accurately reflect how many observations are in that stem. So you want to make sure that each of those is kind of an equal spacing vertically. Let's make some comments here. You must always include a key. So I really need to specify what each number in this stem plot represents. So let's do that with a key. Okay, so that's a little introduction to stem plots. Now let's go ahead and look at a more thorough example. Who's taller, males or females? A sample of 14-year-olds from the UK was randomly selected using the Census at School website. Here are the heights of the students in centimeters. So what I want to do first is I want to create a stem plot for the male distribution. And if I look, I got 150s, 180s, 160s, 170. So I'm going to choose my stem to be the first 2 digits, and then my leaf will be the last digit. So let's go over here and say we're going to go with my stems 15, 16, 17, and 18, and that represents tens. So 15 tens, 16 tens, or 150, 160, 170, etc. Okay, so now I got to list the leaves, and I got to do this very carefully. Very tedious to do with a list of numbers like this. I almost guarantee with anything more than about 10 numbers or so that you're going to make a mistake. It's very difficult to do. So I'm going to cheat here a little bit. I'm going to go ahead and go to a spreadsheet. And notice I have the data here. I'm just going to sort it. If I sort it from smallest to biggest, that'll be much easier to make our stem plot. So I'm not going to disturb this original data. What I am going to do, though, is copy it And I'm just going to paste it over here. So that's the same exact distribution. But now what I'm going to do is I'm going to sort it. So I'm going to sort that from smallest to biggest. Let's do that. Boom. Now it's much easier to see how I can construct my stem plot. So I've got a 150, 54, 57, 59. So 1479 is going to go in as leaves on the stem of 15. And then for the 160s, I have 2, 3, 5, 5, 7. Oh, geez, let's see if I did that right. 2, 3, 5, 5, 7, 9er. And notice that I'm paying close attention to making sure I line up each leaf vertically. Now I'm into the 170s. So I have a 4, 5, 6, 7. And then last but not least, the 180s. I just have 180, 3, and 7. So 0, 3, 7. Okay, that's great. So one thing I like to do now is just quickly identify what the center of this distribution is. I'm probably going to need that later. So that looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 observations. I'm just going to make a quick note of that. We got 17 observations here. So let's see, half of that would be 8.5. So the ninth observation is going to be right in the middle. We'll have 8 below that and 8 above that. The ninth observation is right in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right there is my center. And notice when I'm counting up from the center, I always start with the smallest observation and work towards the biggest. I need a key for this stem plot because I told you the key is always required. So I'll do my key down here. So 15 and then the vertical slash there, and 7 represents. Okay, so there's my key. I hit all the requirements there of creating that stem plot. But when I look at the females, that's a bit trickier. Holy cow. So I want to do something different with the female distribution because I have more observation. Let's see, it's 17, 18, 19, 20, 21, 22. I have 22 females. And 22 observations in the female distribution. I'm going to do the same thing over here with my data for the female heights. So I'm going to go ahead and copy it over a column. And then I'm going to go ahead and sort it. So I've got it from smallest 152 up to largest 169. So I'm going to show you a different technique here. I'm going to do something called, it's called splitting stems. So I'm going to split stems for the females. And I'm going to do females over here on the left. So by splitting stems, what I'm going to do is I'm going to take the 150s and split it into 2 different stems. So I'll have a stem for 150 through 154, and then another stem for 155 through 159. Okay, so let's take a look at females here. I got a 2, 3, 3, and then I jump to the next stem with the 7. So I'm going to go 2, 3, 3, 7, 8, 8, 8, 9. 8, 8, 8, 9. Again, very tedious to create a stem plot by hand. Doing it one time here just to illustrate it. From here on out, we'll hopefully have technology to do this for us. So now I'm into the 160s. I got 0, 0, 1, 3, 3, 4. 0, 0, 1, 3, 3, 4. And now the second half of the 160s. 5, 5, 6, 6, 7, 8, 9, 9. Wow, that's a big one. 5, 5, 6, 6, 7, 8, 9, 9. So again, paying close attention here to make sure I have each of those leaves kind of lined up vertically. I did a pretty good job there just doing it by hand. That's not too bad. Okay, so I mentioned that I was going to do a split stem. So by splitting stems, I split up the 150s into 2 stems, the 160s into 2 stems. But now I'm going to show you another cool feature. And what I'm actually going to do is a back-to-back stem plot. So I'm going to recreate the plot for the males on the right hand side. And it's pretty easy for me to look over at the previous stem plot I did to do that. So let's see, I'm going to have 151 and a 154, 157, 159, 162, 163, a couple 165s, a 167, a 169. I have a 174, 175, 176, 177. I have a 180 and a 183, and then a 187. Okay, so a side-by-side stem plot is a nice way to visualize 2 distributions and kind of make comparisons between the 2. Looks like I did a decent job of lining up my leaves there, so I can go ahead and get rid of that. All right, a couple more comments here. What we did, we're going to call this back-to-back stem plots. And I did it with split stems. And I'll talk more about splitting stems here in a couple minutes. I'm going to keep, the key basically works for both of these, so I'm not going to redo the key. Let's just know that this key works for this stem plot as well as this back-to-back stem plot. Okay, so really all I've done now is kind of just look at a bunch of numbers. I haven't asked the question which was answered, or which was asked. The question is, who's taller? Okay, so I think a good way to answer this might be to compare the 2 distributions. And let's do that first by describing the 2 distributions. So I have my description and my comparison hidden over here. Let's take a look at it. The female distribution is skewed left. The male distribution is fairly symmetric. So let's just make sure we hit all of those descriptors. Shape. Check. Neither distribution has outliers. Outliers. Check. And why am I saying that neither distribution has outliers? Well, if you take a look, we're pretty well clustered here with the females and then with the males. There's no observations that are clearly outside the pattern of the data. Continuing on with our description, there's much more variability in male height, which goes from 151 to 187, than in female height. So that's my spread. And I do make a comparison there. I said more variability with males than with females. The center of the male distribution is 167. I identified that over here, and that is taller than the center of the female distribution. I didn't identify that one yet, so let's take a look at that. The female distribution has, I think I counted it up here, it's got 22 observations, so 11 to the left of the center and 11 to the right. That means I need to find the 11th and 12th observation. Whatever the average of those is will be my center. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the 11th and 12th observations are right there. So that's how I came up with an answer of 162 as the center of the female distribution. So I do now have to check off center because I described center. Check. So let's finally answer the question. Males are generally taller than females based on the fact that the center of the male distribution is higher than the center of the female distribution. Okay, last couple things here. I want to make some comments on stem plots and some tips for you to consider. Tip number 1, stem plots do not work well for large data sets. The reason for that is because the stem plot shows every single observation in the distribution. If I had had 200 male heights recorded here, that would be very difficult to show in a stem plot and have it be very meaningful. To consider number 2, 5 stems should be the minimum, but there is really no magic number. If you have too few or too many stems in your stem plot, it can make it difficult to see the shape of the distribution. So if I go back up here, you'll notice I only had 4 stems in the male distribution here. By expanding that to 8 stems, by splitting stems, I get a little bit better picture of the distribution. If you split stems, which we did in that second stem plot, if you split stems, make sure each stem is assigned an equal number of values. You can either split it with 5 and 5, or you can split it into 2, 2, 2, 2, and 2. Last but not least, if the data has too many digits, round them. What do I mean by that? Well, what if you have numbers that are up in the thousands? Let's say you had something like this. 5,215. Well, how would I make a stem plot with that? It depends what the other values are, but let's say they're all in the 5,000, all in the 5,000 range. So what I would probably do is show that like this. I would round that to 5,200, where this is my hundreds, my leaves are hundreds, and my stem is thousands. Okay, folks, that's it for page 2 of the notes. Let's go ahead and shut it down here and ramp back up for page 3.